What I want to do in this short video clip is to explain the relationship between polar substances and nonpolar substances. So I'm going to give you three different scenarios: polar v polar, nonpolar v nonpolar, and polar v nonpolar. So it's very simple, and there's a phrase that I like to use, which is like dissolves like. And that basically means that polar versus polar, if you have a polar substance and it's like if you have a polar solute and a polar solvent, that's good. Unlike my smiley face, which is very, very bad. So polar and polar, they like each other. Nonpolar and nonpolar like each other. So if you have a nonpolar substance like oil and another nonpolar substance like fats and oils, they can mix together. If you have water, which is polar, and alcohol, which is polar and polar, they'll dissolve in each other. The problem comes in with polar and nonpolar, and that's a big fad. Polar and nonpolar do not like each other at all, quite like we see here in this picture of oil and water. Water is polar, oil is nonpolar, and so they do not mix. You can shake it up and you can break the oil into smaller droplets, which will temporarily be suspended in the water, but it will not last. And because oil is less dense than water, it will separate out. It actually kind of gets shoved out of the water. The water's like, bah, get out of here. And the oil all flows to the top in separate. So that's when we have like dissolves like. So whenever you see polar and nonpolar substances, they do not get along, they do not like each other, and they will try to move as far away from each other as possible.